Hi, I'm Dylan Murphy and I'm the Director of Product Management at Ocean. We're a hyperscale data analytics solutions company, and today I want to talk about geospatial analytics in Ocean and how to enrich your analytics with location data. With the adoption of 5G, the increased number of sensors, autonomous driving in electric vehicles, and mobile devices, companies are struggling with the rapid growth of their location data. They're facing petabyte-scale geospatial analytics challenges in the foreseeable future, and these are not easy challenges to tackle. Let's first discuss what geospatial analytics is. Geospatial analytics is simply the analysis of location data. At hyperscale, location data shows up all over the place. For example, companies may store location data coming off a car or location data tied to a mobile device. And the location data coming off a car may be logged at multiple points as part of a trip. There are many examples, and while some solutions obviously include geospatial data, location data often exists in workloads where location is not the only or main focus of the analytics. Let's look at an example where an automotive company is trying to understand performance of their batteries. The company may have millions of vehicles on the road where each vehicle is collecting data every second around their battery performance, temperature data, location of the vehicle, vehicle speed, and so on. They want to ask questions like, what's the impact to the battery when the vehicle is driving through a particular area of interest? What are customers' driving patterns to and from charging stations? How many trips come within a certain distance of a particular charging station? As you can see, each of these questions requires location data to answer. They're easy questions to understand. This type of analytics can be very challenging for companies at hyperscale. First, use cases like these often generate a tremendous amount of data. There are petabytes of data coming off of vehicle fleets each day. A solution to geospatial analytics like this needs to be focused on scale at its core. Secondly, performance of geospatial workloads can be much more challenging than the average SQL statement. For example, let's say you want to join two tables where ID1 equals ID2. So I have my first table and my second table, and my first column is ID, and I want to join on these where ID1 equals ID2. That's something a data warehouse can do very simply and effectively. Now, say you want to join two tables on their geospatial relationship, like whether a line passes through a polygon, and imagine you have trillions of lines to evaluate. So let's say this is a line column, and this is a polygon column. And you want to evaluate, you want to join these tables where this line passes through this polygon. Unless the solution is designed for this type of workload, it's going to be very challenging to scale. While this is one of many examples from automotive manufacturers, we see customers across a variety of industries, including telecommunications, insurance, manufacturing, and more, looking to enrich their data intelligence with geospatial analytics. These new insights will help them understand their current infrastructure, be more nimble, and enable them to create new products with richer data and insights. How does this happen in Ocean? In Ocean, you can store data that represents a single location as a point. You can store multiple connected points as a line, or you can store an area of land like a polygon that might represent a state's border. Ocean has over 120 geospatial functions that help you create geospatial data, get information about geographies, display geographies in different formats, and analyze the relationship between geographies and more. Let's take a look at an example of a geospatial function that goes beyond what you'd find in other data warehousing solutions. In Ocean, you can leverage functions like ClusterDB-Scan to determine what clusters of points exist in a given area. Let's take an example where I have a county and I'm analyzing the battery performance in this county, and I'm looking for points where vehicles are running out of battery. Now, I want to identify clusters of areas where this event has taken place. So I run a cluster DB scan, and I identify a polygon cluster here of common areas where vehicles have run out of battery. This is an example where Ocean has pushed data science into the data warehouse. With location data growing as quickly as it is, Ocean's committed to solving geospatial analytics problems at hyperscale. I hope you enjoyed this quick talk on geospatial analytics in Ocean, and I look forward to hearing how Ocean can help solve your challenges at hyperscale.